Alright everybody, it's time to go over the old video. I want to help you do well on this retake of microeconomics exam number 1, so we're going to go over every question that you just took on this test in case you want to try to take something very similar again on Monday. So come on, let's do it. Now we're going to look at this scenario for answers to questions 1, 2, and 3. Suppose that there's an experiment. There's 100 students. They're asked to choose between Gamble A and Gamble B. Gamble A has a $50 prize. 70% of the time it pays out. That has a expected value of $35 because 70% of $50 is $35. So a 70% chance to win 50 is 35. And there's a 30% chance that you'll win $100. So that's worth $30. That has an expected value of $30. If you combine the 35 with the 30, then you get a $65 value for the expected value of that prize. Now here, this is not, Gamble B is not guaranteed. And Gamble A, you have a guaranteed chance to win something. In Gamble B, you got a 50% chance to win 100, so that's worth 50 bucks, plus a 20% chance of winning $200, and that 20% of $200 is $40. 20% of 200 is 40, plus a 30% chance of winning nothing, which is 0. And if we add all that together, we'll see that the expected value is 95. So since the expected value of Gamble B is more than the expected value of Gamble A, a risk-neutral person would choose Gamble B. But let's hear what Howie says. Question 1. Howie says someone would have to be crazy to take Gamble B. I would always choose to take Gamble A because it's guaranteed to win every time. Why should anyone risk losing? Now, Howie is showing himself to be a very risk-averse person. He is not acting like he understands the odds. The odds are that if you played both these gambles a long time, you would end up being much better off playing Gamble B. But Howie is not understanding the risk, and that's why he's risk adverse. A risk neutral student is likely to choose Gamble B because, so it's not any of the answers that offer A, but he's likely to choose Gamble B because it has a higher expected value. This is not a good answer, likely to choose Gamble B because the student will win something as opposed to nothing with a higher probability, because that is not exactly a good answer. It's not as good of an answer as to express it as a higher expected value of it. The next question on number 3. A student who was undecided about which gamble he would take noticed that the 5 students in front of him all took Gamble B and all of them received nothing. So because he saw that happening, he got scared and he believed that he should choose Gamble A because he thinks that the bad luck was going to keep going. When you hear a trend that's continuing, then you are falling for the hot hand fallacy. The actual chance that this new student is going to win or lose with Gamble B is independent of whatever happened to the people before him, and so he's falling for a fallacy. That's what the hot hand fallacy is. Number 4, a new product is now available on the market which is more efficient, less expensive, and in all measurable ways an improvement on the way we've always done things. Very few people are actually making the switch over to the new product, however, preferring to stick with what they know. Which of the terms best describes the influence on this consumer decision? That is the status quo bias. We stick with things that are familiar, and it's a kind of linked to the loss aversion or sunk cost fallacy. Shaq has 2 top choices for this year's work. Shaq can either work this year in advertising for $5 million, or he can be paid for sports commentary, which pays $4 million this year. The economic rent Shaq earns for advertising is equal to $1 million, the answer. Remember that economic rent is equal to your best choice, let's say the value associated with your first choice, subtracting the value associated with your second choice. this case, because his first choice was worth 5 million and the second choice was 4 million, then the economic rent is equal to 1 million. Moving along. When the price of product P increases 3% and the quantity demanded for product Z drops off completely so that none sell in this market, we can say that P and Z are cross-price elastic, but that's not a choice. We can also say that P has this very strong impact on product Z. The way we would express it is saying that they are perfectly elastic. It's perfectly elastic. That there was a huge impact on product Z. Someone asked me, could I have an example of that? Let's say that the product P is the airlines charging you for carrying luggage. They want to charge you an extra $50 per bag, and that causes people that fly that trip to stop buying product Z, which is in-flight drinks and snacks and things like that. So if that was happening in your market, then we would say that product Z, which is a different product, was actually lost all its business due to a slight increase in a related product. If the price of Monster cookies decreases from $2 to $1, it's cut in half, right? There's a 50% cut in price. And quantity demanded for Monster cookies increases from 1,000 bags per week to 1,100 bags a week. And you think about that, that's a 10% increase in selling of Monster cookies. Then we can describe the market for Monster cookies as having, is it elastic, inelastic, unilastic, perfectly inelastic, perfectly elastic? Well, we would say that it is a relatively inelastic demand relative to price. Now let's understand what we mean by that. You're looking at a huge change in price and it only affecting sales by a little bit. When that happens, we would say that demand is not responsive or is not sensitive to price changes. There was a major price change and it hardly affected demand for Monster cookies at all. So we're facing inelastic demand between points $2 and $1 in this market. When the price of product K increases 5% and quantity demanded for product J increases 11%, then we can say that there is an elastic cross-price relationship. And so we see elastic demand relative to cross-price, elastic demand relative to cross-price. So either A or D is the correct answer because they both have an elastic cross-price. Now let's break it down. Why is it cross-price? Because we have two different products. When there's cross-price, is only happens when there's two different products. If it's the same product, like product K and product K, then it's just normal. But if it's two products, like product K and product J, then it's cross-price. So that's, of course, all the choices are cross-price, but that's how you determine it. It's a demand because it's a quantity demanded that gets affected. And it's elastic because when the price changed by just a little, the quantity changed by a lot. And if you look at your card or that chart that we were looking at, you know that a small change in price having a big impact on the way that consumers buy, a change in marginal behavior, means that the behavior of the consumer is very sensitive to price changes, and we should know that. So lastly, that's why we know it's elastic demand for cross price, but we have two answers that have elastic demand for cross price. So what we need to do is figure out whether K and J are substitutes or whether K and J are complements. Now, the way that we can learn that or write it onto our card is that if both the direction of the change in the stimulus and the response are the same, then it means that they are substitutes. And the reason for that is because if the price of product K went up, then people will buy less of K. And if they're buying less of K, then they will buy less of the complements of K. But what we see here is they're actually buying more of product J, which implies that product J is a substitute for K. And since people are buying less of K because it's a higher price, they choose to buy J instead to satisfy whatever their need is, and they must be substitutes. So the correct answer to A is that one. If that word right there, increases 11%, was changed to decreases, then that would mean that product K increasing by 5% hurt product J, and that would mean that K and J were complements. And that's the other part of that equation, if you will. If these two values are different, then they're complements. If they're both the same, then they are substitutes. All right, let's go. When Australia offered a $3,000 baby bonus for infants, and you say, baby bonus? Why are you asking me about this? This is in this economics class, and this is what I have to say about that.
I don't know nothing about birth and babies.
All right, very good. And then we...
Let's do it.
No, let's not do it. Where am I back to here? All right. Australia, this is a true story. Back in 2004, that the government was concerned about Australia having a negative population growth. So the number of people in Australia was getting to be a smaller number each year. People were dying faster than new people were being born, and the government decided to subsidize births by offering anyone who had a baby after July 1st would be able to be eligible for this $3,000, the baby bonus. Now, some people were already pregnant and they had wished they had known this law was going to be passed, and other people decided when they heard about the law to start their family a little bit earlier. They did respond to incentives, and of course you can imagine a lot of people didn't let it affect them because $3,000 isn't enough for them to change their marginal behavior. However, if we take a look at the actual numbers, we'll see that, for instance, in June, the week of June 3rd to June 10th, the average number of births per day was around 600, maybe 650 or something like that. And the next week it was similar. There was an unusually low day around June 12th. Happens to be a good day to be born, I know. And then June 17th, that week, was very typical, about 620, 650 births. And even in the beginning of the last week in June, we had very typical numbers. But what we see is in the last couple of days of June, right before this big $3,000 baby bonus was going to be paid out, that the number of births dropped from around, let's say, 620 down to something closer to 400. So that meant, like, in those last couple of days, that there was about 1 out of every 3 moms, or 200 of the 600 women that were going to give birth, about 200 of them each day, seemed to have tried anyway to put off their natural birth or their cesarean or whatever that might have been by just resting and hoping that for waiting a couple of days that they might be able to get the $3,000. That's how they drew the line. If your baby was born on July 1st or later, you'd get the $3,000. If it was born before July 1st, then you didn't get the $3,000. And of course, that didn't make any difference to these people because it was too long to wait, nothing they could do about it. But for those moms that were right on the margin, some of them decided, evidently, to try to hold off on giving birth, which is really quite a statement when you consider the power of incentives. And if you know anything about somebody in their last trimester, they're really ready to have that baby. So that's quite a testimony that anyone would even attempt it. And what we then see is there's another lesson here. This huge jump in D attracts our eyes because we think this is the thing that gets our attention, all the babies that were born on July 1st. But of course, we would have expected about 600 of them or so to be born on July 1st anyway. It's the thing that amazes me, the marginal behavior change, is the behavior of those moms on the last couple of days in June, and that's why E is the correct answer here. The area on the graph that represents the marginal behavior change, the act of delaying, is in fact E. That's the correct answer. That's a tricky one. Well, not tricky, but that one requires a lot of analysis and thought, an understanding into people and and an understanding of graph information and so forth. So a difficult question, but a really useful, insightful question as well. If you could have data, you can explain data. You can use economics to explain much of human behavior, because much of human behavior is in fact influenced by rational decision making. Okay. Number 10. On the television show Mythbusters, the hosts design experiments, collect data, and test theories based on popular myths. This is an example of the scientific method, just like we use in economics. Okay, now we get into the Monty Hall problem. Here, I think I got a little Monty Hall action going here. There he is. Well, that's not Monty Hall, but let's make a deal, the modern version of it. We'll see what that has to do with it. Imagine a game show on television where one lucky contestant is presented with 3 doors that are numbered 1, 2, and 3. Behind one of the doors is a $100 bill. Behind each of the other 2 doors is a goat, which has a value of 0. After the game ends, the contestant will receive the amount of money that is behind the door he or she ultimately decided to claim. The host of the game show asks the contestant to choose one of the 3 doors. After the contestant makes a choice, the host opens one of the remaining 2 doors to reveal a goat. At this point, 2 doors remain unopened: the door that the contestant originally chose and the door that was not opened by the host. The host subsequently asks the contestant if he or she would like to keep the original door or change doors to the other door remaining. If the contestant does not change doors and stays with the original door, the expected value of the game is $33.33, because there's a 1 in 3 chance that they chose the right door on the first try, and if they stuck with it, then they have a 1 in 3 chance of winning $100, because the chance of choosing the right door in the first guess is 1 out of 3, and 1/3 of $100 is $33.33. That's how it's calculated. What should the contestant do? And the answer is they should switch, but you got to switch for the right reason. You switch because the odds of winning the $100 improves by switching. I know that your intuition may tell you otherwise, but if you had chosen, say, door number 1, and then Monty Hall opens up door number 3 to show that you are glad that you didn't choose number 3, then the chances that you have chosen the door with $100 behind it is 1 in 3. The chance that the door number 2 is the door with the $100 is 2 out of 3. There's 2/3 of the time you're going to find that switching will give you the winner. 1/3 of the time switching will give you the loser. 2/3 of the time switching will give you the winner. Play the odds. Use rational decision making. Don't be swayed by false intuition or your gut feelings or fallacies in logic. Switch. The odds of winning are improved. Okay. 13. Choose the best answer. If the price of gasoline increases 8% and the quantity demanded for gasoline doesn't change at all, then we have a situation of perfect inelasticity. The market demand for gasoline along that particular price differential has not been affected at all by 8%. That's what inelastic means: insensitive or completely unresponsive. Perfectly inelastic means completely unresponsive to the change in price. 14. When consumer income increases 15%, so this is an income question, and quantity demanded for product H increases 5%, well, we can say that there is a inelasticity, not perfect inelasticity, but inelasticity, because this was a major increase in your pay, but you're only buying a little bit more of H, so that's inelastic. It's an inelastic demand relative to income. These words about price should be changed to income, as I indicated to you in the class when you took it. And we know that it therefore is either B, inelastic demand relative to income, or D, inelastic demand relative to income. But which one is it? Is it an inferior good or a normal good? And the definition of a normal good is one where the public buys more of it, which we see here, when the public gets more money, which they do. So as the income increases, the demand for the product also increases. That would be a normal good. Therefore, 14D is the correct answer. If it was an inferior good, then we would find that as people were getting paid more, they would actually buy the product less. The only kind of products that get bought less when people's income increases are called inferior goods. It's not a slam on the good itself. It's just an observation by economists what happens when incomes increase relative to the buying of the product. If the price of Skippy peanut butter decreases 10% and quantity demanded for Smucker's jelly increases 20%, then we see that Skippy peanut butter and Smucker's are related to each other in an elastic way. We could say a cross-price elastic because there's an increase in peanut butter. Peanut butter got a little cheaper, and people ended up buying a lot more jelly. So that's what we mean by elastic. We poked the jelly market a little bit, and we got a lot of response out of the jelly market. So that's elastic, price elastic. Market demand is cross-price elastic. That's the answer, C right there. Because it's two different products, peanut butter and Smucker's jelly, that makes it cross-price. And because it's a small amount of change in price leading to a large change in quantity being bought, that makes it elastic. The answer is C. All right, we have a nice little cartoon here. We're looking at this third panel right here. I'll compare ingredients, I'll compare brands, I'll compare sizes and prices. Maybe I'll drive around and see what other stores have. So much selection, so little time. Consider that third panel. Which economic principle explains why consumers do not engage in the research strategies described? The reason is because of rational ignorance. The amount of time it takes to gather all that information is inefficient. You could also say that it's the law of increasing marginal cost, because the cost of gathering that information, any additional helpful information, becomes more and more expensive. So I would have accepted either one of those or both of them as a correct answer for 16. Harry paid more taxes every month than he actually owed. He did so because he wanted to get larger refund at the end of the year. And then Harry pays a fee when he files his taxes in order to receive his refund earlier. Got another nice little slide here. There's certain things that you just shouldn't do. It's a nice little piece of financial literacy. Don't use pawn shops, except maybe to buy stuff, never to sell it or get a loan from them. Check cashing outlets are a terrible way of losing money. It's very disadvantageous. Payday loans, again, take a huge amount out of the amount. Car title loans are very expensive, not a good deal for you. You can do better than any of these things when you need money. And rapid refund lenders, well, it's your money. You shouldn't have to pay for it. You can just be patient and get it without having to pay extra. In fact, you could have got it last year by not giving so much to the government in the first place. Back to where we were. So we would say that it's inconsistent intertemporal decision making on Harry's part, that he was willing to go without his money for the whole year and then ended up paying extra to get his money a few weeks earlier for the refund. That's inconsistent, and it's a sign of irrational thinking or bounded rationality. Below are determinants for the price of elasticity. Which one would influence consumers to be more inelastic? Well, here's what we're looking for. Actually, this is a great thing to think about. Substitute goods are prevalent in the market. If there's lots of substitutes, then people will be willing to go to the substitute if the price of the product we're looking at increases. So that makes them very elastic in regards to price. So since we're looking for things that would be more inelastic for a product, we're looking for items that would make people more inelastic, then substitutes would not be a correct answer. That substitutes cause things to be less inelastic, or you might say more elastic. The price of the good represents a large portion of consumers' budget. People are very cautious when they're spending a lot of money, so that makes them more elastic as well. So this is more elastic, this one's more elastic. Advertising associated with the change in price does not change elasticity at all. Decision to buy or not is made in the long run. long run and having lots of time to decide makes you more elastic because it gives you more choices and more ability to think about it. If the product is a luxury good, that also makes it more elastic because people can put off buying luxury goods. They can't put off buying necessities. So necessities are inelastic, luxuries are elastic. So that means that all of B through F are elastic qualities. It must be that the product is used by people in the consumer's peer group causes inelasticity. And if you know anything about kids in your neighborhood, as soon as enough of them get a certain kind of starter jacket or Nike shoes or just the same kind of thing, then that other kid has to have it as well because kids in their peer group have it. Or keeping up with the Joneses. It's not just kids that do this. There's lots of people. They have to show that they're in that group by buying something, and they'll pay extra for it, and they're very inelastic. All right, just a few more. If product A increases price by 8% and the quantity supplied for product A increases 18%, then we'd say because this was small and this was large, that it's elastic. And because it's supply, then it's a market supply is elastic. A. Product A decreases 10 and the demand drops by 7. That makes it inelastic, but that's not the choice here. We're just trying to see what happens with these two. Is product A decreasing in price? Yes. And the demand for product B also decreases? Yes. So if product A went down in price, then people will start buying more of A. And if they're buying more of A, then they're buying less of B. And if they're buying less of B because they're buying more of A, then they are substitutes. Good. Product A and B are most likely substitutes for each other. Which are these substitutes? Coffee and donuts? No, they're complements. Jif peanut butter and Skippy peanut butter? Yes, those are substitutes for each other. Got a little song for you here, too. Where are we? Here we go. Alright, classic 60s song. Beer and pretzels, compliments. Car washes and oil changes, compliments. Here we got their difference curves and their budget lines. And this one is very similar to what you're going to have on the makeup test. So I'm just going to change things around so that the budget constraints are different. I think I keep the curves about the same. I move the numbers around a little bit, the letters around. So what you're looking for here is an explanation as to why the budget last week was different than the budget this week. And you notice that with the budget this week and last week, we can buy the same amount of Y. So there was no change in income, because if there had been a change in income, we'd either be able to buy more Y or less Y, but we buy exactly the same amount of Y with the same amount of income because we have the same amount of income this week as we did last week. But we can buy less X, so that must mean that X has become more expensive. And so the price of X increased this week. That's what we gather from the budget curves. We see that last week we were able to buy combination C, and it gave us a lot of happiness, right? This is very happy, but impossible. We'd like to have combination B, but we can't afford it. We can afford combination C, at least we could last week, and that gave us some level of happiness at indifference curve 3. But when the price of X increased, we had to make some choices, and what we did is we bought less of X, and it looks like we bought a little bit more of Y. And when you buy less of one thing and buy a little bit more of the other, that is what we call the substitution effect. Shall we play the song again? That's right. I'm just doing what I can to help you remember what we're doing here. Substitutes. All right, now, last three questions. Which combination of goods provide equivalent utility to the consumer? Well, in this one, there's nothing on that one. There's only one letter on that curve. We're looking for anything that's on the same curve. C has got only one A, has got A, D. Okay, A and D. So the answers are, you would circle on your, you would put into your into the Scantron, you would mark A and you would mark D, because that would be the answer, A and D. Consider the demand schedule picture. Choose the graph which best represents the data provided. This can be tricky, but if we take a look at it, This is a perfectly elastic demand. That's a somewhat elastic. This is a unit elastic. This is an inelastic, and that's a perfectly inelastic demand curve. So when we take a look at the prices, are the demanders in your market responding to the changes in price? And the answer is yes. Every time we drop the price $25, we gain 50 more customers. And which one does that look like? It looks like this one right here, my friends. A drop in price of 25 gives you twice as many, there are 50 more customers. So, and that's what we're looking at there. And finally, when Beatrice heard a happy song, here we'll get it going here so we can have it in the background. You ever see this, 24 hours of happy? That's for some people, that's not even enough happy. And I'll play a little of, there he is, okay.
Let's do it. One day.
So, well, you all know the song. Maybe you're like, please don't play it, Mr. Stannard, or, I gotta hear that song now. But she thinks she'll never get sick of the song. She could listen to it all day, every day if she could, and Beatrice appears to be an exception to the law of decreasing marginal utility. But we know that she's not an exception to the law of decreasing marginal utility. She will, in fact, maybe not get sick of the song, but she's not going to want to listen to it 27 times a day for the rest of her life. She will scale back. Economists know that eventually, even Pharrell fans will succumb to the natural laws of economics. Thank you, and peace out. See you Monday.